Alright, so today we are going to simplify expression using properties of exponents. Today's is a little bit different. I keep having to look at this to make sure we do it right. Yesterday, you will see when we were doing our exponents, we were multiplying two numbers, and when we multiplied the numbers with their exponents, if they had the same base, we were able to keep up and then add the exponents. It was like this. 10 and 10 were the same base, so it became 10 to the 11th power. When we came down here, we had to multiply our coefficients. Then we had to match up our variables and put them in order. Today, we're going to have something a little bit different. If you look at your little foldable, it's going to be page 2. And you go in here. But I went ahead and on mine, it's not on yours. If you go to my content library, you can go copy this picture. But I copied these two and put them in there just to help. We're going to be talking today about powers of a power and powers of a product. So, what powers of a power say, and I actually think this picture does the best job of explaining it for you. Any number A and all integers M and N. So it says, just like our example here, x to the n power, and then it was being times by an exponent, by n. The way we do that is kind of distributive, where this n is going to be multiplied to the exponent. So when you have a number with an exponent and we put an exponent on the top of that, you don't add the exponents, you will multiply. So this answer would come out as x and then m times n. Yesterday we added exponents. We added them when I did something like x to the n power times x to the n power. Now we're not doing that. We're using the exponent to times by everything. If we look at the picture I put in there and you do a number, for example, this might help it make more sense. If I did 3 squared, which we know is going to be 9, but if I did 3 squared and I said I need to cube that, that would equal, just like we said here, I'd still keep my base, 3. But now my exponents we multiply. So 2 times 3 is 6. So my answer is now 3 to the 6th power. Or 3 times 3 times 3 times 3 times 3 times 3. Okay? When we have power of a product, two numbers are being multiplied, and then we put the exponent on the outside of them, that is the one where you must distribute it. So I have x times y, and on the outside, I'm putting all that to the n power. So this would end up going to the x, and I would have x to the n power, and I would have y to the n power. What do you mean?
Well, like, do you have to put a sign in between them?
No, if you just have with our variables, when we have just variables that are together. Now, here's the example. They even did this one with a number, so we'll just write it out for you guys. That's why I like this picture. They did 3a, and they did it to the 4th power. So that simplifies to 3 to the 4th power and a to the 4th power. And then could I simplify that any? Well, yeah, we could find out what 3 to the 4th power is. And then you'd say, I don't know what that is off the top of my head. 3 times 9, 27, and 81. Okay. So that would become 81 a to the fourth power. Really, I think the biggest thing that we're going to have troubles with today is mixing up yesterday's when do we add the exponents and when do we multiply. So, we'll keep moving forward. We'll get over kind of the rules and then we'll get into some examples. This one's not too hard as long as we pay attention to it. It says powers of -1. So like here we have a -y, -5, -3. Even powers of -1 are equal to 1. Mainly, if you have a number and it's negative, and I put the power, the exponent is an even number, it comes out even. And that makes sense. Think about it. If I do a power of 2 and I have a negative times a negative times negative equals a positive. If I did odd power, then it's going to come out to a negative answer. Well, yeah. If I did a -2 times -2 times a -2, 3 negatives would give us a negative answer. So that's all this one's talking about. If we solve this first one, I have -y to the 6th power, or I'm multiplying the power of 6. So I have a -y, but my exponent is going to be a positive 6. Should y be positive or negative then?
Positive.
Good. Because 6 is positive, y will become positive, and I'm a power of 6. That's all we can solve. That's simplified. So -y, and then if we took it to the 6th power, it becomes the same answer as y to the 6th power. If we did the second one, now be careful on this one, because this is, this example, power of a product. We have -5 times x, and then we're taking it all to the power of 3. So you should be breaking this up into -5 times the power of 3 and x to the power of 3. And what will this simplify to? Huh? What do you think -5 to the 3rd power will become? Did you say it? What did you say? Good. So 5 cubed, 5 times 5 times 5 is 125. And it's a negative because it started off at negative and our power was 3. It was an odd number, so it stays a negative. And then our x is cubed. Go ahead and do -3 times y to the 4th power. Simplify it. See if we can come up with the same answer. Okay, walking around, most of you guys are getting it. I like how I see people showing the steps. So first I had some people saying this is going to become -3 to the 4th power, y to the 4th power. And since it's a -3 to the 4th power, it's really just going to be a positive. We could just change it. We could just drop it off. To be honest, on today's homework, when we grade it tomorrow, on Monday, on your answers, you could leave the answer like this, I believe, on most of them. You could just say +3 to the 4th power times y to the 4th power. But since it's asking us to simplify, we want to get in that habit. So I can simplify this. 3 to the 4th power becomes what?
81.
and we'd have y to the 4th. So let's practice some. I'm going to go ahead and pause my video. Here's what I want you guys to do. Work on these next 6. Work with your neighbor. Check with your neighbor. Raise your hand if you have questions. I'll be coming around. I'm going to walk around and see what you guys are doing, then I'll come up here and do a couple of work and see if we agree. Marker there. Okay. So here's a couple things. And this is a good kind of question. On the very first one, you could have easily just done 6, and then you have a power of 2, and then it's being multiplied by the power of 3. So it would have been 6 to the 6th power. However, they asked, Josie said, well, couldn't I have done 6 squared first and got 36? And just simplified this on the inside first and said, this was 36 and then cube it and say 36 to the 3rd power. Yes, they will come out to the same answer. Okay? It would come out to the same. But the reason we're looking at like 6 to the 6 is the best part is power of a power, that little part up here where we leave this. This is usually the most simplified. Remember, in math, we want to use our smaller numbers when possible. So if I'm going to be having this and saying 6 to the 6th or 36 to the 3rd, well, 6 to the 6th is easier. It's a smaller number. We just have the bigger exponent, even though they come out to the same final answer. I'll send your homework tonight. If you have the number, you do not have to take it all the way to the farthest answer. Let's just simplify it down. So I would be okay with you getting this for your answer instead of 45,656 or whatever it came out to. So if we look at number 2, when we solve that one, this is how I would be setting up, showing every step. I notice this is going to be that second one. This is going to be the power of a product because something is being multiplied in here. So I'd have this first number. I would say -3 to the 5th power. And I'd have B, and it was to the 2nd power already, but I'm going to be multiplying the power of 5. So 2 times 5 is what? Oh, it's 6. It's like, oh boy, we got problems. All right. Now, does the -3 to the 5th power, does it change to a +3 or does it stay -3? It stays -3 because our power was a negative number. You can leave your answer like this. You don't have to go -3 to the 5th power and find out that's negative whatever it is. Okay? So number 3, same thing. I would be breaking each one apart. I'm going to see I have 3 parts to this one. So I'd have 5 to the 4th, J, 2 times 4 is 8, and K to the 12th. Your answer should have been 5 to the 4th power, J to the 8th power, K to the 12th. Do we get the same kind of things? People are clear what we're getting at? Rob?
Why didn't you do the 3 times itself 5 times?
3 times the what?
Times itself 5 times on number 2.
Oh, right here's, what did I do? -3 times 5, or -3 times -3, -3. I said you could, and if you get the answer to be negative whatever, that's fine. Or we can leave it here with the exponent. This is like a simplified equation. Okay? You don't have to solve this all the way out. All right, so number 4. Ooh. What do you think we have to do at number 4?
Distribute the whole thing.
Yeah, so we're going to distribute this. So that would give me 6a to the 2nd power times 3. Oh, hold on. 6 Come on, marker. 6, I only did it on part of it. 6, and then
2a. 2a to the 6th.
I wonder if this was supposed to be an exponent in here. Because why would we not have it? Hold on to this one. I want to look and make sure. I'm going to think. I don't know why we have that. I bet this is supposed to be a power. Anyways. Now I'm confused myself. I want to make sure I'm doing this right.
You confuse yourself, that's fine.
Let's forget about this one. Here we go. I want to try this. I'm going to show you guys a question because, to be honest, I'm questioning myself and I want to make sure we do this right. So, if we're ever confused, this is what we can do. Because I want to make sure I get this right. The question is, should this be 2 times 3 is 6, and then 2 times the a squared is 2a squared? Or is it just 6a squared? Because I heard some people saying, yeah, we have to do the 2 times the 3 and then the 2 times the a, right? It's distributed. Or if it's this. Obviously, we're going to get a wrong answer, one of the one. One of the two is wrong. How can we find out for sure which one's the right answer? Let's put a number in for a. So if we tried this right now, let's just say an easy number. Let's do 2. A was 2, we'll pretend. If we did that, this would have been 4. So we'd add 3 times 4. And then you'd add 2 times 12. And so my answer should have been 24. Huh? Well, we're just going to run off because we're checking something for distributed property. Now, if my answer should have been 24, when we put 2 in for A, which one of these two is going to be correct? The bottom. If we put 2 in for here, this would be 6 times 2 squared. 2 squared is 4. And this is 6 times 4, which is 24. Okay? So, this is why when I ever get confused, and I doubt myself on part of this, that I will go ahead and I'll just put a number in and solve it and see which one would have worked. This, what we're getting confused on with our distributive property is we're kind of breaking it up too much. We're saying I'm taking 2 times, forget the exponent for right now. I'm taking 2 times 3a. I'm having 2 groups of 3a. That will only give me 6a. And then the power is still to the second power. Okay?
So distributing isn't really distributing, it's like just to the first one if there's...
Yeah, where we're having it, it's just going to that one. I know, it's going to be fun. We have one in here. So, and I don't know why this 3, I really think that was supposed to be a power. I swear, I think this was supposed to be up here. And if that was a power, then we would say 6 to the 3rd power, a to the 6th power. Okay. be kind of fun. Oh, okay. Let's look. This is going to be interesting when we do this one. When we do number 5, the first thing I'm going to do is I'm going to solve this one. Okay? Because my exponent's on the outside. So we can still write this one out. Negative AB to the 5th being times by A to the 6th power. Now, when we go to multiply these, I am having negative A times 5B to the 5th power times A to the 6th. We want to make sure I'm not throwing you wrong. I know that one's right. I just really doubt myself on this one. And that's not a good thing. Because now I'm having second thoughts and something on this. I was going to say it would be A to the 5th, B to the 5th. But it's done. Okay, so we're going to jump down to this one. We'll finish up our review and then you guys can work. I'll look and make sure on Monday we'll talk about those with the distributive. So, examples with numbers. Go ahead and solve. What do you think these answers will become? Do the examples with numbers and do the examples with variables. Okay, we'll pause it. Alright, let's go ahead and check this. We only have a few minutes left. Examples with numbers. What did you get for 2 to the 3rd to the 4th power? 2 to the what? 12. Now, this one, being careful, this is the power of the product. So, what would we have got on this? 3 to the 3rd power, x to the 6th power, y. Good. Examples with variable. X to the what? mn. And then this one? Alright. We are going to stop. I went back and I looked at your homework today. I'll still talk tomorrow when we have more time on Monday about these two. The way I was trying to tell you and I wanted to tell you, I checked in your homework. It is correct how I was doing it. But, like I said, I just feel like it will take a little bit of time. I want to make sure we understand. So, we'll finish that up on Monday. So, your homework will be 8.2. Do not do... Don't do 13 through 16. That's the one that I said I'll talk to you on Monday on. Yeah, you guys want to do evens again?
Yeah.
Alright. Today, I'll allow you to do evens. Next week, we won't be cutting it down as much. But, evens. I do have the worksheet, so I'll hand it out to you.